Hello everyone, welcome to In 5 Minutes. The next question is, in the circuit given below, find the reading of emitter if it has negligible internal resistance. So we have to basically find out, this is the emitter here. We all know that emitter is used to measure the current in a specific branch. So we have placed this emitter in this branch, and finding out the reading of the emitter is nothing but calculating the current in this particular branch. So now practically we will use emitter, put it here, and the reading of emitter will give us the current in this branch. This time when we are calculating this on paper, we can now easily remove this emitter, have a short circuit branch here, and mark current in this branch and find the value of the current, which will be nothing but reading of the emitter. The question mentions that emitter has negligible internal resistance, which is very important because ideally any emitter should have internal resistance which is equal to 0, so that it does not offer any resistance to the flow of current. It must allow the original flow of current through that particular branch, which is only possible if its internal resistance is equal to 0. So let's find out what is the current in this particular branch. So as I said, the circuit that we are going to consider is of 8 volts with 5 ohm resistor here. This is 10 ohm resistor, this is 20 ohm resistor. Here we had 10 ohm resistor, and what I'm going to do is I'm going to simply remove that emitter from that branch and mark the current in that branch as Ix. Now we don't know the direction of the current, so what I'll simply do is I'll mark the current in downward direction, because I can easily make out that the battery will supply current from its positive terminal. So through both the branches, current will be flowing in downward direction. So that's how I'm marking Ix, so that now the value of Ix will come out to be positive. So we have to basically find out what is the current through Ix. For that, let us first find out what is the total current the battery supplies. Let me call it I. To find the total current supplied by the battery, I will first simplify this resistive network, in which this 20 ohm and this 10 ohm, you can see, are connected between two common ends, and hence they are in parallel. So the equivalent circuit will look something like this. So 20 and 10 ohm in parallel I can combine, and that will be one single resistance. This is original 10 ohm, this is 5 ohm resistance, this is 8 volts battery. 20 in parallel with 10 will be equal to 20 into 10 upon 20 plus 10, which is 200 upon 30, which will be nothing but 6.667 ohms. And now all these three resistors will be in parallel, and that will give me 8 volts battery and single resistor. I'm sorry, all the three resistors will be in series now. So the equivalent resistance here will be nothing but a sum of 10, 6.667 and 5. So these three resistors added will give us 21.667, and hence 8 volt battery here, and this will be 21.667 ohms. So the total current that the battery is supplying, which is equal to I, becomes I is equal to 21.667 divided by 8, and that will be equal to 0.3692 amperes. But this is the current supplied by the battery. This is not we were looking for. We were looking to find value of Ix. So what I'll do is I'll once again draw the original circuit. This time we have some extra information, which is that what is the current supplied by the battery that we have in the circuit. So this was my original circuit, and we were looking to find Ix because this is a branch where emitter is connected. We have now got, this is 8 volts, this is 10 ohm originally, this is 5 ohm, this is 30 ohms, this is nothing but 5 ohm again. So we have got the current supplied by this battery, which is I. Now this I will also flow through this 10 ohm resistance and be available here. From here, this I will split into two branches. One will flow through 30 ohm resistance, and one will continue to flow through 5 ohm resistance, which we have called Ix. So you can see that your current is going to divide into two branches which are connected in parallel, and hence to find out the value of Ix, I can use something called as current division rule that we have already discussed. So what will be current division rule applied to this circuit? I want to find out current through 5 ohm branch, that means Ix. In that case, you consider opposite branch resistance, which is 30 ohm, divided by sum of the two resistors, which is 30 plus 5, into the total source current. The total current which is entering to these two branches is equal to I. This is further equal to 30 divided by 35 into I is 0.3692, and therefore my answer Ix, which will also be the reading of emitter, is nothing but 30 upon 35 into 0.3692, which comes out to be 0.3164 amperes. So by finding the current in the branch in which emitter was placed, we also find the reading that emitter will otherwise show to us. So whenever such is the question, you can always replace that emitter with a short circuit, define current in that branch and find out its value.